All right. Hi, everyone, and a very warm welcome to everybody, and good evening, good morning, good afternoon to where you're from. My name is Jonathan, and we're going to be kicking off today with Data Engineer Camp's Demo Day. So over the next hour and a half or so, we're going to be going over an introduction over the bootcamp, just really quickly to give you some context around what the students have done over the last 16 weeks and how they got to this place. We're also going to then dive right into the project presentations over the next 45 minutes or so. We have 5 project presentations today. And finally, we're going to end things off with some networking to get to know the students, but also the students to get to know data engineering industry professionals. There will be a bit of discussions, a bit of prompts and questions we'll discuss over the next 20 minutes towards the end. All right, so to give you some context around who our students are and where they come from. So our students range from a number of countries, such as the US, Canada, and also parts of Oceania, which consist of Australia and New Zealand, Europe, Asia, and South America. So we have quite an international cohort of students this time around, with 31 students in total. And some of them are here today with us to present their final projects. Our students also range from a number of backgrounds prior to joining the bootcamp, such as data analyst. That's probably by far the most common background that our students come from, but also a lot of different roles and backgrounds that they come from prior to the bootcamp, such as data scientists, software engineers, technology managers, and also, of course, we have people who are already data engineers that are looking to upskill in their existing roles. The bootcamp was taught by highly experienced staff members who have been working in data engineering roles at companies such as Canva, EY, Telstra, Rocket, Nielsen, Servian, and so on. The students have completed 16 weeks of curriculum, starting off first with data engineering fundamentals like Python, SQL, AWS, and Docker, before then moving on into frameworks and tools that abstract away those lower level fundamentals of data engineering, and covering topics such as Airbyte, data ingestion with Airbyte, data warehousing with Snowflake and dbt, data modeling and semantic layer with Preset, Lakehouse with Databricks, orchestration with Airflow, and real-time data processing with Kafka and ClickHouse, and finally CI/CD and infrastructure as code with GitHub Actions and Terraform. All right, so just a quick call out that the next cohort is kicking off next week, and we have 10 seats remaining in the next cohort. We have 20 students currently enrolled. All right, now without further ado, this is what we're here for. We're going to kick us off with project presentations. We have 5 projects presenting today. The first is James and Clayton on Twitch Stream Analytics, followed by Deeshal on Fantasy Premier League ETL, Mary on Northwind ETL, Mark on Jobseeker API, and Sneha and Rostand presenting on NYPD Analytics. All right, I'm going to stop sharing my screen now and hand it over to James and Clayton for your project presentation.
All right, cool. Can everyone hear me?
Yep.
Right, welcome. We're just going to quickly introduce ourselves. I'm Clayton. I'm actually located in San Diego, so I'm technically on the clock, so I'm checking my Slack messages in case I have to do anything for work. But I'm a senior product data manager at this company called scientist.com, and I work mostly with well, I have like a hybrid role. I'm kind of like a product manager, and also I deal with processing data. The data part's the annoying part, which is why I ended up signing up for this course. And my partner in crime is James. I think he will introduce himself now.
Yeah, if everyone can hear me, my name is James Hill. I am currently a demand analyst at Carlisle Interconnected Technologies. It's an aerospace and defense manufacturer. We provide cables, connectors, a lot of the components you see in military and defense aircrafts, commercial aircrafts. And so what a demand planner does is I'll make forecasts on our revenue, and I'll tie that back to our operations team so that way they know how to execute properly. So if we see a ramp up in revenue, we may increase our headcount, increase inventories, and vice versa. So that's what I currently do. Some of you may know, but Clayton and I are in a funny time zone relative to the class. So being based in Southern California and taking a class in Australia translated into both of us having to wake up for the class periods from 3 a.m. to 6 a.m., which in a weird way worked because we were both able to attend the class while also working full-time jobs. But it was, of course, extremely difficult. And yeah, sanity was lost, but it's for a good cause, right?
I'm a night owl, so it was even harder for me to do. But oh well. Anyways, so let's introduce our project. And basically, for our final project, we had the idea that we wanted to use one of the last technologies that we learned about, which was Kafka. And we were thinking, oh, Kafka is about like real-time streaming. Let's pick something a little bit fun. And we were thinking, oh, Twitch streamers, Twitch streaming, Kafka streaming. Like, that sounds like a pretty good idea. And so that's how we came up with this project idea. So our project is Twitch Stream Analytics.
This is the screen you can see, right? The Twitch.
Yeah.
Okay. Yeah. So, and then also we both like video games, so it's relatable to us. So I'll get into the problem that our application attempts to solve. So the problem is Twitch streamers face the challenge of engaging with their audience in real time due to the sheer amount of viewers they can have during their stream. And the rapid pace of Twitch chat makes it difficult for streamers to process each message and understand how their content affects viewers. So in essence, Twitch streamers get lots of viewers for their streams, and it's difficult for them to process and understand how their content is affecting their viewers in real time. And so that's where we kind of come in with a solution.
I would say this tool is more for Twitch streamers who have a bigger following. It's not really for streamers who are aspiring, don't have that many viewers, because they probably don't get too many messages, Anyways, with an automated system, we thought that people using this tool could be able to analyze Twitch chat in real time, and then they could get like real-time insights into like what's happening during their stream, like how users are responding, to like the type of content that they're sharing. And just overall, we think that when you take away this aspect of like analyzing these individual messages, it allows like the streamer or the moderator to like focus on their job rather than focus on like responding to each individual message, which is almost like impossible, right? So we were hoping for our use cases that you could either like be a moderator and use our product, or you could also be a Twitch streamer and use this tool for either thing that you need to do.
All right, so we'll get into the how are we doing this?
So for our source, we used the Twitch chat, and the tools that we used were Python, and we used the socket library. It was easy to create a Twitch chatbot to relay the messages from the Twitch stream, because there wasn't really a Twitch API to like pull real-time messages. You needed to create a chatbot that connected, that actually joined the chat room so that it could like receive the messages. And it uses this simple IPC inter-process communication, so we could receive messages once we connected to the chat room. And each message that came in was this like really, really long string. And in order to like make that string useful, we need to like process the stream and transform this string and make it more useful. So that goes into the transformation step, where we use Python. We use this library from Hugging Face called Transformers that actually takes the message after we parsed it out and gives us a sentiment label and gives us a sentiment score. And it was really nice because this particular library had like a out-of-the-box pre-trained machine learning model. So we didn't have to go and like train the model ourselves, and we could just use it out of the box. And basically, once the message was processed, it would give you like a positive or a negative label and then it would give you a sentiment score. And from our understanding, that sentiment label combined with that sentiment score tells you like how accurate that processed message is, like that specific sentiment label. So like if something was like, let's say a message that someone said was like, hi, nice to meet you, was like a positive rating, and the sentiment score is like 0.99, that'd be like 99% accurate in like its review of that message. And then we used some SQL after the fact to clean up some of the tables that we got, because it was just a pretty messy string that we got from the Twitch chat. I wish we actually included the Twitch message original text there. That would have been nice.
Oh yeah, I think, yeah, it was an IRC message string. After we transform it, we ingest it into Confluent. And the reason for that was, well, it's managed Kafka. It's a cloud service provider. It allows real-time streaming, and it integrates pretty well into ClickHouse. And then for our storage, we use ClickHouse because, well, it's a real-time database, so it supports our streaming needs, integrates well into Confluent. And then the way we integrated Confluent is we use ClickPipes. ClickPipes is an integration tool, and it makes, well, integration extremely easy. And that was the case for our project.
And for serving, we used Preset because it was free, and also because it easily connected with ClickHouse through a connection URI. And it was really easy to create metrics through their UI. So that was why we chose Preset. Also, it was the tool that we learned during bootcamp. So.
And then here's a picture of our full architecture, just for you guys to reference all the steps that we just went through. And so with that said, I'll go ahead and get started on this live demo. So let me set this to auto refresh every 10 seconds. And so here's a channel, a website that shows all the live streamers currently, the amount of viewers they have. One moment. So I'll go ahead and use this person right here. Sec 4.
Hopefully this worked. It worked yesterday.
Yeah, we tried it out yesterday, so there we go.
So you'll see as the messages come in, they each get processed. And our dashboard so we split up our dashboard into like two parts. One that we thought that would be more useful for streamers. So we actually wanted to like answer some of the questions. Like once we got the data, we're like, how can we make this data actually useful, right? And so for the streamers, we wanted to see like, are their viewers going up? Are they seeing more viewers come in over time? If you look at this chart on the right where it counts the number of the types of messages, it's a time series where we'll see like, if they go back after the fact to like see their stream, they'll see like, oh, when I was streaming this type of content, users were overwhelmingly positive or negative about that topic. So they could see like, oh, I should focus more on this type of content next time I start streaming. Or they see like it's overwhelmingly negative. Unfortunately, the color schema for this preset seems to be problematic for us. Obviously, the blue one should be the positive one, but the red one is actually the positive one. It's misleading right now.
Color scheme was a little funky with preset, but we can get past that, then you know, it's fine. Another feature we added was we have our problem users. So for moderators, when they want to, those Twitch chat messages come in like extremely fast. And if moderators want to focus on certain users that tend to be problematic, we have a list right here of, the top 10 users who have negative messages that they've been sending to the stream.
And the good vibes one is just a little fun thing that we added there. Those are like the positive messages. We want like the streamer and the moderator to see like, oh, their streams like is fun, so they can be pumped up by their own stream content, and then they'll just be happy to see these are like the messages that are positive about their stream. And I think this average sentiment score over time, it's a little bit confusing, but we basically thought this might mean like how accurate their
confidence of the model.
Yeah, the confidence of the model is at that time, basically. So the closer it is to the 1, the more accurate the model is. Whereas like in those like dips, you'll assume that the model is not quite as accurate. So we took a look at like some of the messages, and a lot of times like it made sense. So this would be like if we go to our next slide, unless people still want to see these good vibes, we can continue with our next slide.
Yeah.
Yeah, that was that. Next slide. So we can kind of talk about our go back one. Some things we've learned, right? And getting things to work together was not always as simple as just connecting the dots. We found out very quickly that even though like things look like they would work seamlessly together, oftentimes you needed to like change this here and then change that there. And that goes into like the next line, where whenever your pipeline broke, sometimes it wasn't exactly where it broke that needed fixing. You needed to change something upstream. And just error handling in general, I think that took the majority of our projects, was just like looking for resources to help us figure out like, why did this not work? How do we get this to work? So, and like just the sheer amount of tabs you need open on your browser just to be able to do a simple project like this. And really, once we had the data, I thought that, oh, it's really cool that we have all this data, but then what do you do with it? So that actually took a lot of time and a lot of discussion between us to figure out like how we can make this data more useful for the user, for us. And yeah.
And then looking ahead, one of the things that we wanted to do was we wanted to use Airflow to run both the producer and consumer simultaneously for the data ingestion. However, we had to, due to a lot of the difficulties with Airflow, we decided to cut that out, and we would just ingest into Confluent and have ClickHouse sort of be our consumer with that, as opposed to going with that architecture. One of the things that we would like to do in the future is improve the code so that way we can allow for multiple channels to be streaming into this, streaming to Confluent at the same time. Training our own models. We'll get PhDs while we're at it.
Well, it'd be cool to see, like instead of using their out of the box, like there's some things that like one side, a non-PC person might find, not offensive, but they might think, not that I'm saying we're not PC, but like they might find that positive. So it'd be nice to be able to train our own models one day and see how that would, yeah.
And for fun stuff, GG's,
It's bunch of
ADHD.
random messages. This one's unfiltered. So we actually filtered the live dashboard to only show positive message. This one should have all sorts of messages.
Yeah. There any questions or comments or anything? Well, first, I guess, thanks, Jonathan, and everyone for spending all this time and months teaching us. I remember when I attempted demo day a few months ago in, what was it, June or July? It was pretty crazy seeing some of the projects being done. I was like, this is insane. Like, am I going to be able to handle this? You know, give it enough time and you can definitely you can accomplish a lot of things, and it's pretty crazy, especially when you got good help. Clayton was a lot of fun to work with, and yeah, collaborating with people can be difficult, but at the same time, it can make you a lot more effective because you see each other's blind spots, and yeah, it just makes you go a lot further. More people you have.
Oh, thanks, James. Thanks, Clayton. If does anyone have any questions, feel free to drop it in the chat or yeah, raise your hand and welcome to ask questions. Did someone raise hand? General, I thought I saw your hand went up or something. Did you have a question?
Yeah, true. Hi guys. Thanks for sharing your work. Actually, you mentioned in your chart that you did the transformation before you send it to Confluent Cloud and Kafka. And
Yeah.
I'm interested in, could you a little bit elaborate where did your Python script actually live? It was on a local machine, or did you spin it up somewhere in the cloud, right?
Yeah, we actually we did everything on our local machine because we kind of ran out of time. Plus the holidays came up. So yeah. Also, I want to build on that a little bit. So originally we had the idea of sending the messages to a topic and then using a consumer to read from the topic before we transformed the data. But then because of the issue that we ran into with Airflow when I was trying to configure it and it just wasn't working, we decided it would just be easier, and we wanted to have something for a demo day and for presentation day. We decided to just
okay. Sure.
We decided to move the Python transformations to right before we sent it to the producer. I sent it to the topic so that we'd actually just have data that we could access and use. So yeah, that's why we did it that way.
Okay, thanks.
We do have like another branch where we're trying to get that portion to work, but yeah, it'll take some time.
Right. Okay, thanks.
Oh, thanks, guys. Thanks, James. Thanks, Clayton. There are no further questions. We'll move on to the next group. So the next project is by Deeshal on the Fantasy Premier League ETL. Over to you, Deeshal.
Thank you, Jonathan. I'll just share my screen. So, hi everyone. Thank you for attending. My name is Deeshal Hanzary. I currently am working as a senior solution consultant for a company called Highland Software. So we have mostly products in the ECM space. It's a company based in Cleveland, Ohio, in the US, but I am based in Perth, Western Australia. So as you will see from my title page, my project, my capstone project is about building a fantasy Premier League ETL data pipeline. Move on to the next slide. So what is Fantasy Premier League? For those who don't know, the Premier League is the highest level of football in England. So it's the highest level. So there's multiple divisions. The Premier League is the highest level one. And the Fantasy Premier League is an online game in which players choose a virtual team composed of footballers in the Premier League teams. And then depending on how the teams do in real life, you collect points. And the aim is basically, to get the highest number of points to rank, I guess, among the top players. I put a couple of screenshots here to show how the game looks like. So this is my team currently. There's a couple of features in the game, like, for example, you can have mini leagues where you can play against your friends, your colleagues. These are the mini leagues that I'm in. So I play with my friends from uni, from my ex-colleagues, friends from futsal. So I'm quite engaged in the game. So why did I choose to this project? So one thing is for this season, there's over 10 million players worldwide that are participating in the game. So it's very competitive and it's very difficult to rank high. By rank high, I mean a rank of 250,000 would be considered ambitious, and it's a good target. So even though it seems like quite low, it's actually, in the grand scheme of things, it's quite good. So it is very competitive. Second is the games themselves, they generate a lot of data. So whenever there's there's data being generated for the teams, for the players. So there's a lot of data to go through. And as a player, it's just too much to manually shift through the website to look at the different statistics for the different players. So it's just too hard. So I thought that I'd sort of automate that in a way and make it easier to get that information. And as you can see, like, I've put my current season's ranking. So I'm at 2.8 million at the moment. So I'm not doing very well this season. And I've got a lot of red arrows, which means, it's not going well. So my hope is that the data that I produce would help me with my rank. For information, my best personal rank, because I've been for a few years now, my best personal rank was in the 450,000. So it's all right, but it could be better. Yeah, if I move on to the next slide. So what was my solution for this? So one thing was to create an automated scalable pipeline to gather all the raw FPL data that's generated and produce analytical data sets. And out of those data sets, create data visualizations that can help me or like any other player, make better decisions for the future game weeks to improve our ranks, to win our mini leagues, win our head-to-heads. So how I went about doing that? So here's my solution architecture for my project. I've gone with a fairly conservative tech stack. Nothing fancy, but the idea is that this whole solution can run completely on the cloud. Some of those components I run locally just because of cost, but the idea is that everything can be on the cloud. So if I run through this architecture, so my first step is that the Fantasy Premier League, they have an API, a REST API that's used on the lab website. So I wrote a bunch of Python code to be able to query those API and retrieve the data sets for the fixtures that we have, the different game weeks, the statistics for each of the players, the results. So I grabbed the raw data. So it's in JSON format. So once the data is retrieved by my Python code, I convert them into Parquet file, and I send them to an S3 bucket. And then using Airbyte, because Airbyte has like a default Parquet connectors, so I transfer the files. I convert the Parquet files to data that's like in a tabular form into a Snowflake data warehouse. And then on the data warehouse, I have my different schemas where I run my dbt code to transform the data into a series of dimensions and facts table. And I've got one big table in there. And from those data, I created a dashboard and some charts for that's hosted on preset. All my code, so my Python code to extract the data, that's so I've containerized them, built an image, and push them to Elastic registry on AWS. And then I've got the ECS task that's running that executes the code. So it's the same, I guess, for my DBT, for when I use DBT to build my my dimension and fact tables. That's containerized as well in one application running on AWS. For the orchestration of everything, so I use for my workflow management, I use Airflow. So basically, so I've got one, I guess like one ECS task here. I've got another one here. And I've got Airbyte in the middle. That's transferring my Pocket file data to Snowflake. So Airflow is basic. So I changed the whole thing with Airflow. So if I move to the next slide, this is what my Airflow DAG looks like. So this is my first task where I extract the data from the REST API. These are my Airbyte Airbyte synchronizations for the different Pocket files. And then this is my last DBT build where I'm creating my data models basically. So yeah, it's just running locally, so it's sequential, but the idea is that this would be simultaneous. If I go back to this here, so I use also GitHub Actions for my CI/CD component. So obviously all my code is on GitHub. So whenever I push any Python code that's related to my extraction, I've got a GitHub action that basically runs my PyTest. It builds tags and pushes my my image to ECR. And I've got another, so this here as well, like whenever I do a change to any of the DBT model, I've got a GitHub action that again like compiles to, I guess runs a model, and then builds like the container application that would perform the DBT build basically. So if we go to the 2 slides forward, these are my actions that I've configured with the GitHub actions. So yeah, it starts with like installing my dependencies, logging into AWS. So AWS, we use like the GitHub OpenID connector provider to be able to allow the GitHub action to assume the role and to be able to connect to AWS. So I run my PyTest, push my extraction code to ECR, pushes my DBT transform image to ECR, and then yeah, just does like some cleanup. So that's why I use like a GitHub actions. And yeah, and at the end result I presented on I've created a number of if I go forward to my dashboard, so I've yeah, there's a few more that I wanted to do. There are some data which I just couldn't find a way to present it neatly on a graph. But basically, like for example, like this one on the top right would be the teams who have the least expected consistent goals. So you want to have, for example, defenders from Arsenal, from Aston Villa, from Man City, for example. So you can use these charts to make to make better decisions. This is one I'm keeping an eye on. It's like so whenever in football, whenever a player accumulates 5 yellow cards, they have an automatic suspension. So the idea is that you don't want to buy a player who's going to be suspended soon. So I'm just keeping an eye on the players who are approaching suspension, not to target them. The bottom one on the left is So these are the defenders who have been involved on the attack more and also considered less. So I know, like, for example, I want to target players on the top, I guess, like top left. So basically players who considered less but have been involved more in attack. So these are choices that I've made to, I guess, to make better decisions. I say, like, there are some data which there is one data set that I created, but I just couldn't present it, where I take into consideration the players who perform better in the last 5 game weeks, but who are facing the teams who have performed worse on the last 5 game weeks. I tried to present that on the data on scatter plot chart, but it just didn't look right. But the data set is there. So yeah, that's like the final result of the work. So if I go to my last slide, so this one just like so we got to challenges. There's been a lot. So because we had to learn a lot of tools, that it's been very challenging to not just complete this project, but like all the projects before, running through all the coursework. So it's been challenging. But the one, if I had to pick one, I think the one thing that I would say was the hardest was to troubleshoot like issues on the cloud, to go through the logs to find like where to look. Sometimes some of these were very challenging, I guess. Lesson learned, if I had to pick one, I would say it's about learning the concept. So if you think about any of the tools I've used, like Airbyte, there's always an alternative. You could replace it with the Tran, Meltano, Apache Airflow. You could replace it with Argo, Prefect, Luigi. There's always an alternative. So it's all about learning the concepts. And so if you learn the concept, the tools will follow. Like, you can go through the machine, so you can learn the tool, but I guess at the base, learning the concepts is like the most important thing. Next up for me, I need to properly document, because I learned so much. I need to go, even for this particular project, I need to go through and document everything, because I will forget if I don't keep in touch with it. So I need to document all my configurations I've done on AWS, on Slovak, everything. And I guess I need to continue learning about data engineering tools and concepts. Yeah. So that was it. Sorry. Thank you for attending. If anyone has any questions, happy to take them. Comments in the chat.
Awesome.
Yes.
I see a lot of people congratulating you. So well done, Deeshal, on your project.
Thank you.
All right. Yeah, if folks have questions along the way as well, please feel free to just drop your questions in the chat as we go along. Yeah, and we can address them at the end of the presentations. Cool. Thanks, Deeshal. We'll now hand it over to the next presenter. Our next presenter is Mary, who will be presenting on her project on Northwind ETL. Over to you, Mary.
Hi, everyone. Just want to double check first that you can hear me okay. Yep. Okay, perfect. I'll share my screen and get started. Okay, welcome to my presentation. So first, just to introduce myself. My name is Mary. I'm situated in Toronto, Canada. So the class for me, definitely not as bad as for James and Clayton. It was 6 a.m. to 9 a.m. here. So I would close one laptop and open the next laptop to start my workday. In that sense, it worked out quite well. I work for a national books retailer. The name is Indigo. So I work in the analytics team here at Indigo, and I've always enjoyed more of the data side of my work. So I was interested in pursuing this course to further deepen my understanding and knowledge around concepts of data engineering and the tooling as well. So for my project, I chose to work with the Northwind retail dataset. One, because I'm very familiar with retail data. That's kind of my bread and butter. And I also wanted it to be relevant to what my team does as well, so that I could show them some of the tools that I've used and potentially talk about what are some new concepts or tooling or whatnot that we might be able to adopt and see how that might benefit our team as well. So of course, the objective of the project was to create an ELT pipeline, in this case, moving data from the sample Northwind PostgreSQL database to Snowflake, which was my data warehouse of choice, and create some curated tables that could be used for reporting and insights. Some classic kind of BI/analytics questions that we would want to be able to answer with these data sets. Things like how are orders tracking over time? How is our premium membership program performing? So in this case, I added an element of a loyalty program to the data, primarily because I work very closely with loyalty data. The loyalty program at my job is a very big component of what we work with in terms of data and how we execute, for example, targeted offers to customers. So metrics surrounding loyalty members, or in this case, premium, so for example, paid memberships, is very important for us. And then typical insights such as like which categories are performing better. So the final data that I wanted to get out of this was some orders data, so a facts table and a few dimension tables. So in this case, I have information around the customer tier. So this is what indicates whether they are a basic or a free tier or a premium/paid tier. Like I mentioned, the supplier as well, and some product data. Here you see a quick snapshot of what this looks like in my Snowflake instance. So I'll explain what each of these three databases, but you can probably take a guess. So the solution to architecture that I used, also pretty basic, pretty, I guess, standard, in line with what we learned in the class. For me, it was really about trying to solidify the concepts that we had learned and using tooling, like I mentioned, that I'm familiar with or that is directly relevant to my workplace as well. So in this case, I had the PostgreSQL database hosted on an Amazon RDS instance. I used Airbyte to ingest that data into a database in Snowflake, which in this case is this Airbyte database that you see. And then I used dbt to do my transformations and testing to land it into either the prod or the dev database, depending on the run. And from one of the Snowflake final curated data sets, which is my one big table, I have a preset dashboard set up as my serving layer. Now from the ingestion and the transformation pieces, those are orchestrated using Airflow. So as I mentioned, the source database is an RDS hosted PostgreSQL database. It contains the Northwind data sets. In this case, the Northwind data didn't come with natural cursor fields. So I enabled CDC on it in order to use that, this one, ABCDC LSN fields, to enable incremental syncs on my Airbyte. So here's my Airbyte connection set up. I didn't take all of my data sets. I wanted to scope down the project a little bit so that I wouldn't spend too much time on the transformations. Then getting into storage. So as I mentioned, the data goes first into a Snowflake database called Airbyte database. And then depending on the profiles YAML that's set up, if the target is prod, the data will all be written into the prod database. If it's dev, then it'll be written into dev. I wanted to set this up so that when I was testing my dbt project locally, I could verify what changes I was making before I went ahead and saved that code, pushed that code to ensure that it was doing what I wanted it to do. So the individual model YAMLs will write to the relevant database depending on the target. Depending on the target set up in the profiles. So for transformations, as I mentioned, I use dbt. The techniques are probably some of the classic ones. So had to change some column data types, created some new calculated columns. So some examples are calculating how many days it took a product to ship, or the concept of what the normal retail value was. So what is like the list price or what the price should be at full price versus the actual retail value. So what did the customer actually end up paying after discounts, for example? Classic joins, some column renaming, and then some tests. So in terms of tests, I used some of the DBT generic tests. So unique, not null, accepted values. I also created one singular test to check for my discount values, which I'll just go here for a second. So for example, my discount column here represents the percent given, but as a decimal. So if it's 0.3, then it's a 30% discount. So I just wrote a singular test to ensure that all the records that have a discount should be within 0 and 1. Otherwise, it's a discount that makes no sense. So we have to flag that. That was also inspired by a work issue that we had recently where we had a points record where a customer earned like 2 million points, and we didn't have any way to flag that at the time of ingestion. So it came up in the reporting afterwards. As another example of something that we struggle with at work is, as I mentioned, the loyalty concepts. So we don't have a clear history of a customer moving through the different tiers of membership. So from basic to premium or back to basic. So we don't know how long a customer stayed at basic, when did they upgrade, how long did they stay at that tier, then they expired, et cetera, et cetera. So we have some versions of tables like that. They don't all quite do exactly what we want it to do. And I think that's because of the way that we're creating those tables without DBT. Now with DBT, I wanted to show that we could use something like snapshots in order to create that history table and clearly see the customer's tenure in the respective tiers as they move up and down. And then, as I mentioned, orchestration. So this is set up as an Airflow. It's quite a simple DAG. So it just triggers the Airbyte sync, runs my DBT project. I did also create some very basic Slack notifications. I'll show you here. It only shows when the project starts. I did not have time to actually implement any sort of failure notification. So that's definitely something I would have liked or will like to build on in future. Because as you can imagine, it's not very handy as is, but it was nice to get it started at least. And in terms of CI/CD, I do have my SQL fluff running my linter checks for whenever a push is made to the main branch. So it does check for SQL formatting. You can see here, there's some failures, so it's doing what it's supposed to do at least. I didn't have the time to get into CD, unfortunately. So that is another thing I would like to add in future. And as I mentioned, the serving is a preset dashboard using one of the Snowflake data sets. So I did have to create some additional metrics in the semantic layer. So the concept of, for example, what percentage of sales are made by premium members, that's also directly analogous to something that we do here. Average days to ship, etc. So there's some basic metrics here in my dashboard, total orders per month, what percentage of orders are made with a discount. So we can track theory over time. Are we too promotional as a company? Are we moving away from promotions, etc.? How is our shipping tracking depending on destination country? How many active premium members do we have? The sales penetration of our premium members, and then which categories are performing the strongest. Lessons learned. So I think this would probably be a repeat of what a lot of people have mentioned already. So decision-making is half the battle. I think a lot of times just setting yourself up for the next step of the project. So planning ahead in a way that you're setting yourself up for the next step when you're working on the current step, so you don't lose time going back. So for an example is I had set up my Airbyte sync and my DBT roles and Snowflake access. And then I decided I wanted a prod and a dev database. So I had to go back and change all of that configuration and all of my user accesses again. So it was definitely a good lesson learned to think about what I would like the end product to be and work more towards that versus just focusing only on the immediate task at hand. Definitely test each component multiple times. So my classmates will know that I had last minute troubles with my Airbyte syncs. I had done it, it worked, and I moved on. I should have done a little bit more testing before I just ran out of time to go back. So I thought I have the data where it needs to be. I'll try to get back to it if I can at the end. as always, the way that you investigate is probably equally, if not more important than the original setup. So when things go wrong, you end up learning more. Error messages, Google documentation, of course, all the things you should be paying attention to. And prioritization, time management, same thing. Definitely focus on key criteria first, get your data where it needs to be, and then you can play around with additional fancy things as well. So I got my Slack notification set up. I was starting to get into trying to get the failures, but then I decided there were other more important checkboxes to tick before I get into that. So all in all, a few things I would have liked to add or would like to add in future: more testing, more notifications, a little bit more on the CI/CD side as well. But I'm overall happy that I generally followed instructions. I think Jonathan will agree, hopefully. And I completed the project, which was fun. So thank you. And any questions or feedback, I'm more than happy to take. I guess no questions or feedback.
Well, if there are no questions, I might jump in with one. What was the most challenging part about the project?
So airflow for me was tricky. I think I just struggled with the original setup more. But once I saw like my task node show up from my DAG, I was like, okay, I get it now. So I think it was more just moving from concept to doing in general. Like I need to be able to get something working one time, and then the concepts will click for me. So I think it just turned out to be that airflow was the one that was a little bit more of a hurdle to get there. I think it was like the end of the course, people were dropping like flies, and we were like, shoot, not really attending the class as much. I tried to attend every single one, but it was hard to maintain the focus throughout the end. So I would say that's the trickiest part for me.
Oh, cool. Thanks for sharing. All right, thanks, Mary. Awesome work with your project, and congratulations as well. All right. Thanks, Mary. Up next, we have Mark presenting on Jobseeker.
Thanks, Jonathan. All right, can everyone hear me and see my screen?
Yep.
Okay.
Oh,
right.
Sorry, Mark. We're
it's showing the other side, huh?
Yeah.
Okay. Okay, that better?
Yeah.
Okay, cool. All right. Okay, so hi everyone, I'm Mark. I'm from Sydney, Australia, and I'm currently working for the state government in their property data team. Our main responsibilities are to maintain the data system that keeps track of everything that the state government holds in terms of land and property. And I decided to take this data engineering course because I'm considering kind of like a career shift. My main focus right now is to just maintain the data and just go through and update information as the updates come through. And over time, that became very tedious and boring. So I ended up looking into ways to improve how we did the current process. So that's what kind of pushed me into the direction of automating as many of our processes as possible. I started out doing a lot of simple things like an Excel and VBA. Then I started picking up Python and found myself to really enjoy these type of tasks. And it's when I found out that this is what data engineers kind of do. So for this project, I decided to choose the Jobseeker API, which is a data set that displays all current job openings in the UK from the read.co.uk job site. So the people that might find this project useful would be those who, like me, are considering a career change. And you might, have an idea of what industry you want to head towards, but not really sure what role you want to do yet. So also for anyone who may be in recruitment who wants to get some real-time insights and analysis on the current job market, this might be of interest. So like I said, the data source I'm using is this API from the read.co.uk website. And it provides information like the job title, the minimum and maximum salaries, the location of the job, information about the employer, and also the current number of applications for that job. I've also added another data set that appends coordinate information to those locations, and that is used to help with the mapping portion of my dashboards. So this is my solution architecture. I pretty much used all the tools that we learned in this course. I've used Airflow to orchestrate the entire pipeline. I built a custom connector in Airbyte, which would then get triggered by the API. So I found some challenges here with the custom connectors, because not all connectors are created equal in Airbyte, it seems. My intention initially was to get Airflow to trigger a API call to create a new custom connector. And the purpose of this was to allow configurability for the type of jobs that can be pulled from the API. But I wasn't able to figure this out yet. So at the moment, the job roles are hard-coded. And the jobs I'm using for this example would be data engineers, data analysts, and data scientists. So the Airflow would trigger an Airbyte call. It will pull the API data from the API, and also pull the location coordinates from a CSV file stored in S3. This information will then be stored in Snowflake, where the DPT transformations will then kick off once the initial ingestion is complete. And then once the transformations are complete, it is then presented in a preset dashboard. In terms of the transformation techniques, I've used the kind of staples of SQL queries. I've also used Ginger to dynamically create some SQL scripts. So the information that comes through the API, all you really have is the job title to categorize each role. And that was not useful because it's essentially free text. So you might have a role that says data engineer or AWS data engineer or senior data engineer. And I wanted to be able to kind of group all those into one category. And because I want the job roles to be configurable, it had to be dynamic. So I used Ginger for that. So when we receive the job data, it sits in a table in the raw stage, which is just simply the information as is. And then from there, we will use the Ginger SQL to then create a table that categorizes all those jobs. Then we'll do some further cleaning to dedupe the records. And then from that, we would then create our facts tables with our dimension tables. And these tables would then form the basis for the rest of the tables that are used for the dashboard. Okay, we'll go through the data set. Okay, so currently, when data is pulled through, the information is appended, and the purpose of that is to allow, I guess, analysis of trends over time. So I don't have a large set of data at the moment. It's only been about a week. So we'll just focus on the initial 3 jobs that I started out with. So yeah, so the final data sets will then be presented in these dashboards, and these will help kind of compare the different roles and versus the things like salary, the location, the number of jobs available versus the number of applications per job. And this is meant to then help the user kind of determine, okay, which job role seems to be kind of like the best kind of path to head down towards. So this dashboard here shows the number of jobs versus the average salary. So you can see here that there are a large number of data engineer roles, and the salary is pretty decent, with some outliers kind of outperforming the rest of the jobs here. This dashboard here shows a breakdown of each role versus the location, and you can see a breakdown of the total number of jobs, the average number of applications per job, and some salary analysis as well. So this map here uses the location information that are provided through the CSV, and then creates a heat map. So if you were thinking about also potentially moving for the job as well, this could help with that decision making. And this last dashboard here, it shows the total number or the average number of applications per role for each of those job titles. And as you can see here, data engineer roles on average have a lower number of applications, which means less competition. So for everyone who's in the next cohort for this bootcamp, I think you made the right choice just based on these metrics. And yeah, that's pretty much it. So anyone have any questions or feedback?
Yeah, that looks good. That's awesome, Mark. I guess that kind of confirms we're in the right industry in some sense, the high demand and low supply of data engineers. Does that affect the price at all? Like, do you notice that because of the high demand but low supply, does that kind of drive the salaries up for data engineers?
There seems to be a correlation. And I think it would be better if I had more kind of information over time to make sure it's not just this point in time. But it looks like, yeah, the fact that data engineers are in high demand, there's low competition, the salaries tend to kind of trend upwards. Because if you look at the data analysts, the number of jobs isn't as high, the number of applications is probably the highest, and the salary kind of expectations are a lot lower compared to data scientists and data engineers. So there's a somewhat of a correlation, yeah.
Any questions from anyone else? All right. Otherwise, awesome work. Good job, Mark. That was an awesome presentation and really relevant as well for everybody in this industry. Oh, up next we have Sneha and Rostand to present to us on your NYPD analytics project.
Hey everyone, can you? I hope you guys can hear me. So Rostand is he's not available today. So I'm going to present the project. I think I'm sharing my screen. So this the goal of our project was to build a live dashboard based off of the data about accidents that happened in New York. We got the data from Open NYC website. It was sourced by NYPD, and we collected the data. So the data was extracted from an API, public API. So that's how we build the extract layer. So a little bit about the business objective, like who would use it. Like main customers would be, not customers, the people of interest would be NYPD and the city of people of New York City, for them to know which areas are more risky or more prone to accidents and what are the contributing factors. And yeah. So I can show that source of data. So basically, this is the NYC Open Data website, and we had actually 3 data sets, 4 data sets on their website. We used 3 of them and we performed dimensional modeling and extracted data from all those 3 endpoints. So this one is the one we drill down the most. Okay. And for technology, I'll go directly to the architecture. So as I said, so we use Kafka, one Kafka producer, which will extract the data from the API. So on the website, they have data available from 2014 to 2023. So for all those years, we wrote a Python script to extract the data, and that was our initial load. Loaded it to ClickHouse, and then for incremental load, since the API updates the data on a per day basis, we wanted more of a real time data, so we had to use a Python library to mimic some of that real time streaming data. So for that, we have a consumer running. So sorry. So that was the extract part, and then we loaded it to ClickHouse, which was a good candidate as opposed to Snowflake, because we wanted a live dashboard. So we decided to load it to ClickHouse and have the data in 3 different tables related to crashes, to the vehicles that were involved in the crashes, and the people that were involved in the crashes. So 3 different tables, and then for the initial load, we extracted the data from the API and loaded it to S3 buckets, and then ClickHouse has capability to directly load the data from S3 buckets. So for the initial seed process, we didn't have to do much of orchestration, but for the real-time updates, I think what our plan was to use AWS Lambda to run a cron job, which will periodically stream updates from the API, and then extract updates from the API and then load it to ClickHouse. But so that it doesn't increase cost, we decided to for now run it on the local machine. So we have one consumer, which is on a live real-time basis, updating, creating new records of these crashes and directly streaming it to Kafka. And then Kafka is pulling it, ClickHouse is pulling it from the Kafka consumer. So that is the streaming architecture. And then we perform transformations on ClickHouse to have those visualizations on the preset dashboard. And yeah, that was about the architecture. I can go a bit deeper into second. I cannot see my screen. Okay. So this was these were the Kafka topics that we created for the Python script to publish to these topics. And then ClickHouse project, the three projects, ClickHouse tables, sorry. And then this is the live dashboard. So this one, I'm going to start a script which will stream the data real-time basis. So this is set to update. This is set to update every 10 seconds. So we should have data updating every 10 seconds. And we have performed joins on the three tables, on the two tables, basically crashes and vehicle table, to have where they have common records to create a view, which then can be used to create a chart. And we wanted to drill down a little bit more into it, but we didn't get much time. So these were a few of the charts that we created. So these are coming from three different tables, and these are the different crashes that happened in the 5 different boroughs. We did have a lot of null values, so we need to know how to deal with that. But apart from that, basically some of the important criteria, like for example, the contributing factor, the major contributing factor here was the driver distraction, amongst all of the other for the accidents from our data set, and the number of people killed by boroughs. Brooklyn has the highest. So that was a bit about our project, and the lessons. I think what we could have done better, I think having Airflow, I mean, it didn't make sense to use Airflow just to stream the data, because rest of it was completely seamless integration. But using AWS Lambda would have made sense for extracting data on a regular basis, because it's an API. In a live in a live environment, you would have the producer directly publishing to one of the topic and then the consumer streaming to it. But we were working with an API, so I think we could have used AWS Lambda to orchestrate that. But yeah, I think that is it. Just want to demonstrate the live refresh, but looks like it's refreshing. Okay, till then I can take any questions if anyone has. I think I saw it change, but yeah, any questions?
Oh, well done, Sneha. I don't see any questions in the chat, but yeah, awesome work. And it's good to have something that's quite relevant to folks living in New York City. Yeah, hopefully, Jay, do you think it lines up to what you've experienced living in the city?
Yeah, actually the dashboard makes sense because Queens and Brooklyn has a larger population, and in Manhattan, the roads are like grids and they're straighter. So it kind of makes sense that Manhattan has the least number of accidents. So it's really interesting.
Yeah.
Awesome. Thanks, Sneha.
Thank you.
All right, we do have actually one more surprise presentation. At the very last minute, Cristian was able to join us. So I'll hand it over now to Cristian to present on your project on an end-to-end data platform using modern data tools. Over to you, Cristian.
Hi all, I'm sorry for jumping in so late. It's actually 12 night here, midnight. So I wasn't supposed to be here today, but I didn't prepare a nice presentation for you guys. So I just wanted to show you one slide of my architecture and then just go through the platform that I built. Yeah, let's see here. Let me know when you see my screen.
Yep.
Okay, cool. Well, the idea, I actually had the first week of this capstone project, I had like a brain freeze. I didn't know what to do. I didn't know what data to use. I didn't know. I searched a lot. I did a lot of, I had how do you say, big ideas of stuff that I wanted to do. And I realized that a whole week passed and I didn't have anything. So for a couple of months, I wanted to test a couple of tools, and I never had the chance to do that. So I just thought that, well, let's just take a database that we all used in this training, the AdventureWorks database that is, probably everybody knows that. And I thought, well, if I just test with that database and I test these tools that I wanted to see, I can build an end-to-end platform. So the tools I wanted to test is an orchestration tool called Kestra. It's a YAML-based orchestration tool. I actually tried to do this with Airflow. I didn't. I had so many problems, so I just thought, well, because I wanted to test both, right? I wanted to see how you do stuff in Airflow and how you do stuff in Kestra. I never managed to do anything. I don't know. I had some problems with Airflow, so I just did it with Kestra. Another tool that I wanted to test was Omni. It's a business intelligence tool from the people from Looker who left they left Google and started this new business intelligence tool. They also have the semantic layer and some dashboards you can build on top of that and stuff like that. So I just wanted to test that out. Also in the training, we did a lot of Airbytes. So I wanted to test that in my own environment to see how that worked. So what I did was that I in GCP, Google Cloud Platform, I installed my Postgres database. I did a backup, loaded the data that we got from the training, and I'm syncing that with Airbyte into BigQuery. Airbyte is also installed on a VM machine on GCP. And that BigQuery data is then presented in these dashboards in Omni. All the transformations are done in dbt Cloud. And I'm orchestrating Airbyte and dbt Cloud from Kestra. Later, then I realized that we also did some real-time experiments in the training with Kafka and ClickHouse. So I wanted to see how I could do the same with PubSub. That would be the GCP alternative for Kafka. So what I did was I used Colab. That's like a notebook you can use for free if you have on Google. And you can run Python scripts in there. And I'm running a Python script that sends a fake event to PubSub. So I do fake events like visits on a website, and I send it through PubSub into BigQuery. And the idea was to see how this Omni dashboard could work in real time. Okay. So what I did is I can show you Kestra. First of all, into this. So this is installed in a I think you see my dashboard now, right? You see the Kestra dashboard?
Yep.
I hope so. Okay. So this is the dashboard. You see here, I'll have a lot of field workflows that I've been running. But you have this VS Code editor in here. You can do stuff with that. But this is really the interesting stuff. You can create flows here, and you can add plugins, or you can add add-ons into these, or actions or tasks into this DAG, and you actually get a form. So you don't need to know all these YAML stuff. It has a form, so you can just fill in the configuration, and it creates this for you. And you can see your DAG in here. So what I do, I have a schedule. I have I ingest the data. I actually just do an API call to Airbyte, and then I do an API call to DBT Cloud to create or run the job. Now you can see all the executions you see here. Since I was late, I didn't know that I was presenting. So I just started my server, and I got a lot of failures, and that's why I'm the last one. Okay, so if I execute this, if I go here, you can see here we have my DBT, and somewhere in another tab in here I have my Airbyte, right? So if I go here and I execute this flow, you can see here it will start to run, right? And then we should see Airbyte. Let's see, something should happen. So it started syncing, right? So we're creating an API call. So we're syncing like nothing, because it's just a database that is static. And then we will load BigQuery, and then it should be, if everything is working fine here, it should trigger the DBT Cloud job. So we will see here something happening here. It will actually run here. So this is just an example of how you could do this with YAML instead of doing all this Python in Airflow. I don't know why it's taking so long, but it is working fine. I think I just ran it. Let's see if something will happen here. I don't know what it's doing actually. This should be, I know it should be starting soon, but anyway, it will just take a moment for it's doing stuff you see here. And actually, it's a very cool thing that you get all the error messages from DBT Cloud and Airbyte in here. So now it's running DBT Clouds, and something should be happening over here. So we see this is running now, and you see all these failures I had a moment ago. That was because I have a contract on my fact table, and I had it enforced, and I changed a field, so it didn't work, and that error message was presented in Kestra, so I saw that in here in the error message. And well, when this data is refreshed, we can see this. This is actually the dashboard that I created in Omni. It's connected to BigQuery. BigQuery is like also an alternative database to Snowflake. It's an analytical database from a Google database. And it works really fine. This is really cool, actually. You can do, you can work with a workbook in here, and you can create new fields And every field you're creating here will actually create a new field in the semantic layer. So if anybody here has been working with Looker, you know that in Looker you need to start doing your views and your metrics in LookML. In Omni, you can actually create that from here. So you don't need to start coding. You can actually do stuff directly from your dashboard. It's really cool. So, and you can actually have different tabs for different stuff you want to add to your dashboard. If I can show you this is actually what's happening behind the scenes. So you're creating the semantic layers, you're telling Omni how to create the joins and how to use the joins in topics. So you can create a topic with a lot of joins, a lot of tables. That could be a star, a mark, or whatever. And that's what's displayed in that workbook, right? So let's see how this is going. Okay, so it's ready. Let's see if it is ready. Over here. Yeah, it's ready. Okay, so now we loaded all data. So we actually did load from this database into BigQuery, and now we can, since the data is static, I can't show you any movement, right? But what I can do is I can run my Colab notebook. So if we run this, I did a small, we see here we have 622 events, and then we have 629 events. I can run this again. And let's see, where is it? We can run this again. We have 636. So it's actually in real time. So for a specific, if you don't need real time, so to say, you can actually just use BigQuery in this case. Depends what requirements you have on latency. So this script is triggering an event, and we're posting it to a topic in PubSub. We have a subscription that is listening to that and just writes the event to BigQuery to a table. And that's what I was presenting in this visualization. So it's a way. I just wanted to see how we could do the same that we did in the training with Kafka with PubSub. So what I haven't done in this project is CI/CD with GitHub. I wanted to do that. I didn't have time since I did this a couple of days before we needed to send it in, and I didn't have time. But that's something that I would like to explore more, and also the security around this. Now I have a lot of servers, and anybody can actually reach my servers, and I don't have any idea how to handle that because I'm not an infrastructure person. Yeah, I think that's it. Any questions?
Oh, yeah, drop your questions in the chat, folks. I did have one, which I wrote in the chat as well. Was it easy to orchestrate Airbyte and DBT with Kestra? Are there like built-in connectors or integrations, or did you have to write?
Yeah. Code? No, there are a lot of different. We can actually do this. We can go to blueprints here, and we see all these. We can actually see if there's a DBT. So you see all these DBT. There are like templates. They're already done. So you can just choose one, and then you get this form where you configure everything, and it creates a YAML file for you. You don't need to start here, or you start with a blueprint and then you remove what you don't need, right? So if we choose one here, what would happen? It would just create a flow for you. And you would just remove whatever task you don't need. Okay, so it was pretty easy. You see, you have all kind of stuff in here, and there are. Let's see here. You have a DuckDB, you have Databricks, so you can do a lot of stuff in here. BigQuery, there should be some. Yeah, I don't know. This is just. There's a Snowflake. So you see here, you have a run a DBT job and high touch sync, send a Telegram message and workflow completion. So it's you have the whole DAG ready if you want to do that.
Cool, very nice. Any other questions from anyone else? Feel free to put up your hand or drop it in the chat. All right, otherwise, awesome work. Well done, Cristian. Round of applause to you. Good job. All right, let me just share my screen now. All right, that brings us to the end of the presentations. We'll now dive into networking. So please do stay on. We're going to have some pretty interesting topics up for discussions. So Douglas, do you just want to introduce the topics we'll be discussing today? And then I'll split us off into some smaller breakout rooms so that we can discuss.
Sure. Thanks, John. And thank you everyone for presenting. I think as I started talking, a siren just started going off in the distance. I'll continue though. The topic for the networking discussion as we break into breakout rooms will be around improving data quality. As companies rely on data more heavily, how can they ensure that data is of the highest quality to inform their decision making? What patterns or techniques have you learned or seen used that may improve data quality? So we'll drop that in the chat and then run off into a few rooms.
Cool. Just drop that in the chat, Douglas, and then I'll create the breakout rooms right now. Do 2 rooms. And open that on now. Here we go. See you in the breakout rooms, folks. So again, just congrats to you, Clayton, and to all the bootcamp participants as well. Did you want to say something, Clayton?
Oh, no, I was saying you have to say everything that you said before again.
Yeah, I'll try. But yeah, so again, yeah, massive congrats. And yeah, I just want to thank everyone for attending as well, for all the industry professionals jumping in to give you advice, to share experiences and participate in discussions. And yeah, having you here has been a great help to students. And yeah, hopefully, I hope that everyone here stays connected and that there'll be future opportunities to network again and for you to kind of like maybe perhaps connect with one-on-one with some of the students and see where it goes. All right, so thanks everyone, and we hope to see you again at one of the future events. All right, see ya everyone. Thanks for joining.
Bye.
Thank
Thank you.
you.
Everyone.
Thank you.
Bye.
Bye, guys.
Bye.
Bye, guys.
Yes.